Welcome to ACA Science Confab. Today we are going to take up on separation techniques. And I want you to know that separation techniques employs physical property of the substance in doing the separation. What is this separation? The separation has to do with sorting out of substances mixed together. Now, I talked about the physical properties like solubility, like particle sizes, like color, and so on and so forth. These are physical properties of substances. We use these physical properties of all these substances to do the separation. Now, number one separation technique that we are going to talk about is sieving. What is sieving? Sieving is a technique used to separate solid particles of different sizes. There must be of different sizes. Example, sand and gravel. If you have gravel mixed together with sand, you use sieving to separate it by pouring the mixture into sieve, and you shake it. The one with smaller particles, which is sand, will come under. The one that has higher or bigger particles will remain on top of the sieve, which is gravel. You have done your separation. Now, industrial application. Take notes. In every technique, you need the particle or the physical property. You need also the example of substances you can separate, and you also need the industrial properties of that substance. Now, industrial application of sieving is Gari industry. In Gari, before you fry Gari, after you finish drying it, you sieve it. The soft and tiny particles that come under your sieve is what you use and fry. Then the bigger particles on top of it, you throw it away. So, industrial application of sieving is Gari industry. Number two, filtration. It is used to separate insoluble solids from liquids, e.g., sand from water. Sand is insoluble in water, so if two of them are mixed together, you can filter it. Use filter paper. Filter the sand out from the water. The industrial application, you can also use it in water industry. You can use it in wine industry and juice industry. Number three, evaporation. It is used to separate soluble solids from solvents. Example, sodium chloride from water. When I say sodium chloride, I'm talking about that's edible salt. The salt you are using in cooking is called sodium chloride. If it pours inside or you pour it inside water, you can separate it after it has dissolved. That technique is called evaporation. How do you go about that? You pour the mixture, the solution into your beaker, put it on a hot plate, allow the water to evaporate out, get back your salt. So, industrial application of that technique is salt industry. Next is distillation. Distillation is used to separate solvent from a solution using Liebig condenser. Take note of Liebig condenser. Example, ethanol and water. When they mix together, you boil it, heat it. The one with lower boiling point, which is ethanol. For example, ethanol has boiling point of 78 degrees Celsius, whereas water has boiling point of 100 degrees Celsius. So as you are heating the solution, the mixture together, the temperature is climbing. It must first meet 78 degrees Celsius before 100, and at 78 degrees Celsius, which is the boiling point of ethanol, ethanol will boil out and you collect it using Liebig condenser. The vapor that is coming out at that temperature is ethanol. Channel it into Liebig condenser is an apparatus in the lab that condenses vapor back to liquid. Then you have done separating your ethanol. Industrial application of distillation, gin industries, where they are doing this local gin. That's where they are using this distillation technique. This is simple technique or simple distillation. Let's go over to fractional distillation. It is used to separate two or more miscible liquids with close boiling point. The difference between simple distillation and fractional distillation is just about this one you are separating one component of the mixture, whereas this you are separating as many as possible, two and above, with close boiling point. For example, you have petrol, kerosene, diesel, gas, and so on in petroleum products, in petroleum or crude oil. So these are all what? Products of petroleum. Using fractional distillation, you can separate all of them. They have close boiling point at so temperature, so component will come out at so temperature higher than this one, another one will come out higher than this one, another one will come out like that till you get all the components of the crude oil. Where it is being used is in petroleum industries. Next is separating funnel. Separating funnel is used to separate two immiscible liquids using density as physical properties. I talked about miscible liquids before as something, two substances mixing very well, liquid in liquid forms like ethanol and water. They are miscible liquids. Now, immiscible liquids has to do with two substances that do not mix well, like oil and water. So take note on miscible and immiscible liquids. So in this case, we are talking about immiscible liquids. Example, oil and water. When you pour two of them together and allow it to stand a bit, they separate out. So when they separate out, assuming you were pouring inside separating funnel, there's apparatus called separating funnel. It has tap. So it will settle down. The one that is denser, which is water, will come down. The one that is lighter, which is um, oil, will be on top. So when you on the tap down here, you see that the denser one that is water, which is water, will flush out first. You put a container, beaker, collect that, lock it when you see that because it's transparent, you're seeing it going. Once it wants to finish, you so it is it has finished, you lock it, shift that beaker, bring another beaker, and then put on it again. Then the oil will come out. You have separated oil from water. So industrial application of separating funnel is vegetable oil industries. Next is crystallization, used to separate solids which decompose easily on heating their solution. There are some substances that when they are in solution, not all the salts in solution that you can use evaporation. Remember we talked about evaporation. So those that you can apply that technique are those salts that you know that they can withstand high temperature without decomposing. But when you see a salt that you know that this one cannot withstand high temperature, it will decompose. You use what? You use um, crystallization on such salt. The one you know it will decompose. Use crystallization. Um, Example of such salts include copper 2 tetraoxosulfate 6 pentahydrate. Don't bother about the formula. When we get to writing of correct chemical formula, you know how it will be written. So this name is what? Copper 2 tetraoxosulfate 6 pentahydrate. So this is a type of salt that cannot withstand high temperature. On application of heat, it will decompose, giving you other things. So in such a situation where you have it in a solution, you dare not use what? Evaporation. Instead, you use what? Crystallization. Now, how do you get this salt? The crystallization, how do you get it come out from the solution fast? Examiner may ask you to mention two ways by which you can induce crystals formation from a salt. One is by one is by seeding. What is seeding? Seeding, you just pick, like you planting seed in your farm. You just pick some seeds of this salt, spray on the solution. It will now hook, those ones in the solution will hook themselves on the seed that you are planting in the solution, and then hold on to it and come out faster. Or use scratching. Scratching, you use something like stirring rod, put in the beaker containing the mixture, and then scratch the bottom. Tiny particles from either the rod or the beaker falling into the solution will serve as seed. So they will hook on them and come out from the solution. So what am I saying? Seeding and scratching. Okay. Now, industrial application of crystallization. Sugar, pharmaceutical, salt industries. Any of these can use that technique. Fractional crystallization, just the same way we talked about distillation and simple distillation and fractional distillation, is this one now. Fractional, fractional crystallization, you use it to get out two or more salts from the same solution. And this salt must be those salts that you know that they cannot withstand high temperature. Okay, industrial application, salt industries. How does fractional crystallization works? If more than two and above number of salts present in the same solution at a certain temperature, do not allow it to reach the temperature whereby some of the salts will start decomposing. So allow it to come down as the temperature is coming down from, for example, maybe 60 to 40. One salt may crystallize out. That 40 is its own what? Solubility temperature. It will come out from the solution, turn solid while still in the solution. You see solution that was clear up, that was solution before. Now you are seeing solid substance. A particular salt has formed. You filter that one out. Keep the solution again. When it goes down maybe to 35, another one that has that as its own solubility temperature will crystallize out, turning solid in the solution. You filter that one again from another filter. Keep, allow it to come down. Another one, pending on the number of salts present. All of them like that will crystallize out from the solution. That is what technique in fractional crystallization. It is also can be used in I mean the application in salt industry. Now let's go to sublimation. Sublimation is a word that we have mentioned earlier, not today. In our previous lesson, one of the previous lessons we had, we talked about sublimation, and sublimation is what is a way of changing a solid substance to gas or gas to to solid without passing through liquid state. So, for example, we all know camphor. You use camphor, you buy camphor in the market, put inside your box. After some times, you go back and check, the camphor is reducing in size, but it's not that it is melting. If it is melting, you will see liquid there. But in this case, you are not seeing any liquid, any drop of liquid, but the size is reducing, meaning it's changing from solid to gas straight without passing through liquid state. So, camphor is an example of a substance that's sublime. Ammonium chloride is another example. Iodine is another example. Sulfur is another example. There are many. I've given you how many? Four. Okay, so sublimation is a method used to separate a mixture that contains a substance that can sublime. Those examples I mentioned are those substances that can sublime from a substance that cannot sublime. Okay, for example, these are the substances examples I mentioned. Now, for example, if you have ammonium chloride, it looks like sodium chloride. Remember, I said sodium chloride is this edible salt. It looks like sodium chloride. Both of them are crystalline in nature. If both of them are mixed together, how do you separate them? You apply heat. Ammonium chloride will sublime, leaving will go out from the mixture, leaving what? Sodium chloride, because sodium chloride cannot sublime. The leftover in your beaker is what? A sodium chloride. Ammonium chloride has escaped. Okay, now industrial application of ammonium chloride out of sublimation is salt industry. Now let's go to magnetic magnetic separation. It is used to separate magnetic substances from non-magnetic substances in a mixture. Example, iron filings from sulfur powder. Iron filing is a magnetic property. What I mean by iron filings is if you have ever gone to where welders are working, you see them using filing machine to file something. You see particles coming out, particles of light coming out. Those particles are the ion filings that I'm talking about, tiny particles of ion. So you can separate them from non-magnetic. For example, where they are doing the filing, if you want to pick them there, you just bring magnet, roll on that place. It will collect, it will catch the particles of iron and will not magnetize sand. Sand will not be part because they are non-magnetic substances. So you can use that to separate magnetic substances from non-magnetic substances. Okay, now industrial application of magnetic separation. It can be used in iron and steel industries. Now question comes. Mention two separation techniques used to separate ammonium chloride from iron filings. Ammonium chloride from iron filings. Two techniques that you can use to separate them. This is why standard question. Now, remember I told you ammonium chloride can be separated using sublimation. It can sublime. So sublimation is one. Now, if you don't want to separate ammonium chloride from that mixture using sublimation, you can separate iron filings from that mixture using what? Magnetic separation. So the two answers are magnetic separation or sublimation. Okay, now let's move to decantation. Decantation is a method used to separate a mixture of liquid and a denser substance. You have sand and water mixed together. How do you do it? Maybe you want to get the water alone. You allow it to settle at the bottom, this denser substance, maybe sand. Then you bend the container a bit, and then it pours, it pours, it pours, it pours, it pours. When the solid particles, the denser particles wants to follow, you stop. That's decantation. So it can be used where? Water industry. The next technique is magnetic separation. It is used to separate magnetic substances from non-magnetic substances. Example, iron filings from maybe sand. Sand are non-magnetic. Iron filings are magnetic. What is iron filings? The particles, if you go to where welders are doing work, when they file out iron, you see particles coming out. Those particles are called ion filings. So you can use magnetic separation to separate them from sand. Now, industrial application of separation, magnetic separation is steel, iron and steel industries. Now, question comes. Mention two separation techniques used to separate ammonium chloride from iron filings. The two techniques, remember I mentioned sublimation not quite long. That sublimation is is a technique used to separate a substance that can change from solid to gas straight without passing through liquid. Now, you can use that to separate ammonium chloride. Remember, I told you ammonium chloride is one of those substances that can change from solid to gas. So, you can use sublimation to separate it. You can also use magnetic separation to separate ion filings. So, the answer to this question is sublimation and magnetic separation. Let's move to decantation. Decantation is the technique used to separate mixture of liquid from denser substance. Denser substance may be sand poured inside water. If you want to get back the water, you turn it gently, 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 gently. Water is going, water is going, water is going. When the sand wants to follow you, stop. That's what decantation. The technique is employed in water industries. Next technique is chromatography. Chromatography is used to separate colors from a mixture. When if I have this color, I want to know whether this ink is made up of red only or is a mixture. I will use chromatography to separate um, different colors present. When they talk about color, when they talk about dyes, when they talk about ink, note these three things: color, dyes, ink, and chlorophyll. They are referring to the technique that you can use to separate the different colors present in them is what? Chromatography. How does it work? You pour a substance that can move in a beaker. Use something like filter paper, suspend it on the cover of that beaker. Pour ink on the paper, somewhere on the paper, and then don't do not allow the ink to be very close to the bottom so that when you dip inside a mobile phase, a solution that will move like ethanol, it will not go inside. So as you fix it there, the ethanol will start climbing the paper and soak the ink and move away from the ink as it is going upper. And all the colors present in that ink will start moving. Remember, we are talking about them using, you use this technique, you use their rate of movement. Some colors move faster than some other ones. And then as they are going, anywhere a certain color cannot move again, it will stop. The other one that's still able to move will move a bit and stop. Another one, if there are three, will go, and then all of them will separate out. When you remove that paper is called chromatograph. You see the different colors line up. If it is just one color, if the color is pure, you see one dot. If it is impure, you see more than one dot on that chromatograph. That technique is chromatography. And the industrial application of this chromatography is in medicine. They are using it in medicine to analyze blood and urine. They are also using it in industry to analyze the component of crude oil. Next is criteria for purity. How do we know whether a substance is pure or impure? Now, if the substance is solid, it will have sharp melting point. If the substance is liquid, it will have sharp boiling point. If the substance is a dye or ink, has to do with color, it will have one spot on chromatogram. The substance must have a fixed density. So these are the criteria to determine whether a substance is pure or impure. I believe you enjoyed the lesson. If you do, like the page and share the page. Keep watching. Thank you.